Hey everyone, and welcome. Today, we're going to jump into something that is absolutely crucial for anyone using Microsoft Access. It's called normalization. This is really the secret to taking a database that's a total chaotic mess and turning it into a clean, efficient, and honestly, a really powerful tool. So let's just dive right in.
So, have you ever opened up a spreadsheet or maybe a database and just felt that wave of being overwhelmed? You know the feeling. You've got names repeated all over the place, addresses you need to update in like 10 different spots, and you're kind of terrified that if you delete one little record, you might accidentally wipe out some really crucial information. If any of that sounds familiar, trust me, you are in the right place.
And this is usually where all those data headaches start. So let's meet the villain of our story today, the unnormalized table. I mean, look at it. We've got everything just thrown in together. Student info, course info, the whole shebang. And pay attention to Alice Johnson here. Her name and her address are repeated for every single course she's taken. Now, this isn't just messy. It's a complete recipe for disaster.
Yeah, this isn't just about things looking untidy. This kind of structure creates very real problems, and we call them anomalies. So for example, if Alice moves, you've got to find and update her address in every single row where she appears? What a pain. That's an update anomaly. Or, hey, what if you want to add a new course that no one has signed up for yet? Well, you can, because there's no student to attach it to. That's an insertion anomaly. You see, this whole system is just fragile. It's just waiting to break.
So what's the solution to all this chaos? Well, meet our hero, normalization. Now this isn't some magic button you press. It's a step-by-step process, a system. And the main idea is actually pretty simple. We're going to break down that one giant, messy table into several smaller, way more organized tables that are all linked together. It's literally how we bring order to the chaos.
So why even bother with all this? Well, the benefits are huge. You immediately reduce all that repetitive data, which saves space and, more importantly, prevents errors. Your data becomes more trustworthy. We call that having high integrity. All of a sudden, maintenance gets way simpler, and you can build these powerful, flexible relationships between your data, all while making your database run faster. It's a total win-win-win.
All right, let's get our hands dirty. The journey of normalization is broken down into a few stages, or levels, and we call them normal forms. We're going to start with the first and most fundamental one, first normal form, or you'll hear it called 1NF.
So the rules for 1NF are pretty straightforward. First rule, every single cell in your table can only hold one single value, what we call an atomic value. So no lists, no comma-separated stuff in one box. Second, no repeating groups of information. And third, every single row, every record has to be unique. And to make sure that happens, we introduce something called a primary key. Think of it like a unique ID number for each and every row.
So here's our table after we've applied those rules. See? Each enrollment now gets its very own row. Now, to make each one unique, we've created what's called a composite primary key. That just means we're using two columns together, student ID and course code, to create one unique identifier. It's like needing two keys to open one lock. So we've solved the repeating groups problem. But look, Alice's information is still repeated. We're not done yet.
Okay, let's move on to the next level. We've got our data into 1NF, which is a great start, but we can definitely make it better. Now it's time to tackle second normal form, or 2NF, and this one is all about getting rid of a very specific kind of repetition. Okay, the big rule for 2NF is this: eliminate partial dependencies. It sounds complicated, but it's not. Remember our key was made of two parts, student ID plus course code? Well, just think about it for a second. Alice's name and her address, that stuff depends only on her student ID, right? It has nothing to do with the course she's taking. That's a partial dependency, and 2NF is designed to fix exactly that.
So, to get to 2NF, here's the game plan. We perform a split. We're going to break our one big table into a few smaller, more focused ones. We'll have a table just for students, a table just for courses, and then a third table that acts like a bridge to link them all together.
And here is our very first new table, the students table. Look how clean and simple that is. Each student is listed only once. And this is that aha moment. If Alice moves, you only need to update her address in this one single spot. That's it. We've just eliminated that huge risk of error. Here, the student ID is the primary key that keeps every student unique.
And here is the courses table. It's the exact same principle. Each course is listed just once with its unique course code as its primary key.
all the information in this table is strictly about the course itself. See how logical and organized this is starting to feel?
Now for the real magic that ties this all together, the enrollments table. It doesn't repeat any of the student or course details. No way. Instead, it uses what we call foreign keys. A foreign key is really just a field in one table that points to the primary key in another table. So here, student ID and course code just reference our other tables. This table now only holds info specific to that one enrollment, like the grade and the semester. So clean.
We have made some huge progress. But there's one more common problem we need to solve. So let's move on to the final main step for most databases, getting to third normal form, or 3NF. Now this one's a little more subtle, but it is just as important.
Okay, so the rule for 3NF is to get rid of something called transitive dependencies. This happens when a field in your table depends on another field that isn't the primary key. So, for example, if we had stored the instructor's office number inside the courses table, well, the office number really depends on the instructor, right? Not the course. That's a transitive dependency, and 3NF tells us we've got to move it out.
And the solution should look pretty familiar by now. We create another new table. This time it's for the instructors. Each instructor gets their own unique ID, and all of their specific info, like their name and their office, gets stored right here. Now, if a professor moves offices, you only have to change it in one single place. Perfect.
And here is our newly updated courses table. You'll see that instead of storing the instructor's actual name, it now just holds the instructor ID, which is a foreign key. So now, whenever the database needs the instructor's details, it can just quickly look them up in the instructor's table. Our whole design is now incredibly clean and robust. Now you might hear people talking about even higher normal forms, like BCNF, fourth and fifth. Honestly, for the vast majority of Access applications, and probably for what you're doing, you really don't need to worry about them. They solve very rare, very complex data issues. Getting your database to 3NF is pretty much the gold standard for most projects out there.
So let's just do a super quick recap of our journey. First normal form, 1NF, got rid of those repeating groups. Then second normal form, 2NF, eliminated partial dependencies by splitting our tables. And finally, third normal form, 3NF, removed those sneaky transitive dependencies by splitting them again. Each step just made our data more and more organized and reliable.
You know, as Ferris Solution puts it, normalization turns a messy structure into a professional, scalable, relational database. And that's exactly what we did. We took something that looked like a chaotic spreadsheet and we totally transformed it into something powerful, professional, and efficient. That is the real power of normalization.
So how do you actually put all this into practice in Access? Well, always define your primary keys. Make sure you use the relationships window to officially connect your tables. That's how you enforce integrity. And remember, just because your data is stored in all these separate tables doesn't mean your users have to see it that way. You'll use queries, forms, and reports to bring it all back together into one seamless, user-friendly view.
So there you have it. We've walked through the entire process, from total chaos to absolute clarity. We've seen how just a few logical rules can completely transform the way you store and manage your information. So, the final question is really for you. What messy data in your world could use a little bit of normalization? I really hope this explainer helped demystify database normalization for you. For a deeper dive and a lot more resources, be sure to visit our website, Ferris Solution. Thanks so much for tuning in.